Yep.
Well, I want to welcome everybody who's on. We'll just have a little chat here for a few minutes. Any stragglers with technical complications? I know we had a fair share of our own, but we want to welcome you and appreciate your patience and navigating the webinar. It's our very first one, so thank you so much for joining. We're happy to have you and all of the NDE practitioners around the world. We're super pumped and excited about this ultrasonic tech. And if I could say, this is just a couple leaves on the tree here because we've got some really big, powerful stuff coming out. So just be patient. And anyway, we're gonna start presenting some of this technology here today in the first webinar. I do ask, excuse me, everyone that's on the webinar, have a listen to the story and the technology. We want to invite audience participation, and so please ask any questions within the chat. And then at the end of the presentation, which will be short and brief and sweet, we want to be able to engage and answer your questions. So please type some questions in if you have any questions about the evoDUAL technology that we're going to present today, and then we'll answer those at the end of the webinar. Without further ado, introduce the panel to you. And we have Chris Rodriguez here. Many of you know Chris. Chris is a seasoned sales executive with over a decade of experience in non-destructive testing, equipment sales, recognized as a trusted technology advisor and currently serving as the U.S. sales leader at EvoSonic USA. And we have Cass Willis. Cass is our technical leader of EvoSonic. After studying physics and medical imaging, Cass moved into the NDT field. He was the very first and the youngest ISO 9712 Level 3 certified by Australian Institute of NDT. 28 years in NDT as both a service provider and consultant for end users, former federal counselor of AINDT and chairman of inspection standards at Standards Australia. Nate Frady is product owner at EvoSonic, over 10 years of PAUT experience. Nate was the first graduate of Warrior to Inspector in Flagstaff, Arizona. He started out as a tech, then moved over to Australia. I had the pleasure of working with Nate as he was an intern of my former integrity consultant company, Riccadelli Consulting Services. So that's where I met Nate. He supported us during his tenure over there at Warrior to Inspector while he was in school, and really appreciated my experience and time with him. And he moved over to Australia, gained multiple certifications under AINDT, and he's the guy on the ground deploying our technology and the first prototypes, seeing the products through their final stages. Nate is so super valuable to us as he's hands-on, right? Nate hands-on practitioner, tests and vets all the technology out there we're putting out. And my name is Sean Riccadelli. I'm a 30-year veteran of ultrasonic NDT, current ASNT level 3 and UTNMT, CWI, and ICC special inspector. Hold multiple industry UT endorsements, and I'm currently the principal of North America for EvoSonic. Who is EvoSonic? Well, we are first and foremost a tech company built of actual UT practitioners and born out of South Australia under the umbrella of NDE Solutions. Our founder, Kamal Singh, built NDE solutions to 100 technicians in under a 5-year period. As a practitioner himself, he felt the urge to create better tech and assemble a team of these phenomenal and innovative physics and software engineers over in Australia, and created what we know today as EvoSonic. And then we're getting closer to release technology. We built EvoSonic USA under the umbrella of EvoSonic, and anyway, that's our story and our beginning. Appreciate that. Time for the intro. So, why are we here? And what is evoDUAL? I'm going to turn this over to our colleague across the water, Nate Frady. Please give him your attention. Nate, go ahead and take us away there, sir.
Yeah, thank you, Sean. Good day, all. First, thank you, everyone, for taking time out of your day to sit in on this webinar. As Sean said, I'm Nate Frady. I'm the product owner here at EvoSonic, and today I'll be discussing some points around our latest product, the evoDUAL. We'll also show you a video of calibration and a quick scan so you guys can see this product in action. To explain the product, I think it's best to explain the story of how the ARC technology was incepted, as that is the step change for this product. So as Sean said, we grew out of the R&D department of a service provider. And from that, the Evo ARC was invented on a phased array campaign in a coal seam gas field here in Australia, where the client was facing several loss of containments per week on wellhead piping due to microbially influenced corrosion, or MIC. So we naturally went down the path of phased array to detect these small internal wall loss pits. And we wanted to find a way to map large quantities of this wellhead piping while still being efficient and to help the client build out corrosion rates. Naturally, as you do, we were looking around and we wanted maximum probe coverage around the circumference. So we leaned towards flexible arrays, such as the Kelpie or the SFA1, which you find on the Rexoform. Once we deployed that kit, it quickly became very, very apparent that marking up the correct, accurate index lines for the kit, that was essentially equating for half the inspection time. So we saw that there might be some efficiencies to be gained there. As we paid attention to the tech scanning, we also found that the positional accuracy from tech to tech on the same spool of piping, it could improve. We started to see this was from relying on the technician as a human to maintain the probe's position over these index lines that they drew, thus adding more time to the inspection as the techs were going back and repeating scans to make sure the data was lining up to help those corrosion trends. From that, the ARC was born. The ARC is a contactless circumferential encoder that could bolt onto any system and track the circumferential position live. The ARC was the answer to the two main factors that we saw challenging the inspection. And with this tech, we ended up giving our client a sensational end product and a very efficient inspection. We negated the need for the index lines and the need for the human to follow those lines and tell the set exactly where the probe was at every index, as you do with like a clicker type inspection. With the ARC, our techs, they only needed to input the datum, input the scan area, press play, and then they were rocking down the pipe. With the ARC, our techs, one of them sent us a video. They were literally spiraling down the pipe, and then they went back and landed on the datum, and the position was dead on 0-0. So after we got the ARC dialed in, we decided, hey, let's take it a step further and see if we can't negate that interface echo that you get with water column probes, as it chews up, about 3 mil from the zero line of your range, because we wanted to see if we can't gain some near surface resolution, which brings us to what we're here for today, the EvoSonic DUAL. So this product combines all the benefits of the Evo ARC as it's built into the scanner for the circumferential contactless encoding, and it combines it with the near surface resolution of the REX1 DLA. And then we're tracking the axial distance with that Omni wheel on the front. So we're giving the techs a two-dimensional encoding on the horizontal piping assets of various diameters and sizings. I just wanted to hit that note that this is for horizontal piping up to 70 degrees from horizontal. So now, I believe this adds a pretty unique tool to any tech's toolbox when inspecting the horizontal assets, as you can paint around OLEDs, saddles, nozzles without having to establish a new datum or measure to the position that you're starting at. And also, just like the arc dual does have positional lights that indicate when it is at 12, 3, 6, or 9 o'clock. So we're assisting technicians with the inspections in more than one way here. Now I'm going to share the video to show you guys some calibration, and then you can see it scanning in action here. Let me just share my screen. Sean, can you confirm you can see the screen?
Yes, man, I can see it.
Fantastic. All right, guys. So here I've got a simple setup. I'm on a clamshell pipe. We've got a manufactured defect here at top dead center. I've got the REX1 positioned in the arc dual scanner there. Big thing to pay attention to, it's one cable coming off for 2 encoders, no splitter required, plugs into any conventional set that you're going to use to map with this tool. From here, the calibration process is the same as any encoder. What we're doing here is my scan axis is going to be my arc. I'm making sure it's on quad. And I'm just going to follow a simple cal procedure. We want you guys to ensure your techs are following whatever company procedure policy you guys have to do. But here I'm going to do a 200 by 200 mil calibration, and then I'm going to scan just the top surface of that plate. So we're punching in the target distance. I'm going to set the dual or the arc dual to 0, clear the position out, and then push it down to the target distance that I'm aiming for, which is 200 mil here. I'm about 1.7 mil off, so I just calibrated that. Now I'm going to scan back to 0 and confirm that the resolution is correct here. I'm satisfied that was dead on 0, so we're going to move to the evoDUAL, or which is my index axis encoder, excuse me. And that type is quad as well. So when you're setting these scanners up here, it's quad. You're not doing any click or anything. And we're capturing data mil by mil for this inspection here. So I'll just repeat the same process. We've got VPA lines on the side of the dual, which I'm using for my reference point to know that I'm 0 and I moved it 200. I'm just lining that line up on my marks on the pipe there. Forgive me, I'm using a paint marker, so we do have some width to the tip. But yeah, we got that resolution dialed in pretty good here. Once that, I accept the cal just as you would. I've already pre-made a DLA setup for the thickness that we're doing. I've already set my gate color palette and all that. So now I'm just going to position the probe where it needs to be using the top dead center light, which you cannot see in the video here. Thing to note is that the arc itself is saying that it is at top dead center when that light is lit up as per our technique sheet or document. You must take into factor that, hey, my probe is offsetting to the side. So you just input that offset distance in the set to ensure that your data is lining up perfectly. So I've got it set. I've checked the top dead center light here. I've hit play. I've already preset the origin or the datum into the set. And now I'm going to paint. As I'm scanning, pay attention to when I index. You'll see that I've went too far with the evoDUAL. And I'll have a sliver of black data missed right here. I've got some black data that's dropped. All I do is simply index back, move back, capture that data, and continue on with the scan and keep that position. And I'll do that a few times, which it speaks true to human mechanics and how technicians would actually pull things down a pipe if they're doing a simple clicker type index. And you truthfully wouldn't be able to see that millimeter change in distance because the set doesn't know to track that, right? You're telling the set, hey, I'm moving 25 mil, where this is actually tracking live. So this is where we're saying that positional accuracy is just next to nothing here. Right there, I dropped some more data just because I'm not centered on the pipe with my body. Coming back, and then we just keep going and capture that. Dropped a bit of data, same side. right there. Yep, I'll pause it. I'm going to show you guys what the bottom of the block looks like now. And then we're going to chuck on the B scan and scroll through it and watch the that feature as we scan down.
Clean and crisp data.
Great, absolute great tool for small corrosion maps, small areas, as well as if you have any, like I said, OLEDs or nozzles to paint around. So sensational tool. With it being coupled with that DLA, the near surface resolution is next to none. Sean, I'm going to stop sharing the video if you want to go back to the slide deck.
After the video there, appreciate that fine work there, Nate. We appreciate it. So we want to engage you into some additional questions here. We kind of ask ourselves, really, as practitioners, you know, why is evoDUAL valuable to the NDT phased array practitioner? What is it about the dual that is really going to make it unique, right? So again, I want to ask to our panel, Nate and Cass as well, all the experience that you guys have, why is evoDUAL unique?
Like I've been saying, it's that positional accuracy for me. As you guys saw, I simply shifted over 1 to 2 mil, and you would not catch that with any type of clicker type inspection if the tech's pulling it one way or the other. So it's we're taking a step change here for results that we're delivering, as well as repeatability. It's sensational being a service company owner myself over here. Just being able to have confidence that our techs are able to help build trend data with this kit. It is the step change in my opinion.
Yeah,
Yes.
and I look,
No,
I
go
think
ahead.
I think as well from a practical sense, it supplements automated scanning as well. So if you've got larger pressure vessel scopes, there's always a whole lot of areas which are inaccessible to those larger automated scanner types, right? And so you supplement that areas with something like this, and you combine it with a superior, like a superior POD and sizing accuracy of a DLA type probe, and you can really give your customer that complete, overall reliable result for their ongoing monitoring scopes. And again, just to reinforce that it's a really compact little scanner. So as soon as you've got complex assets, ones which have vessels or piping which you've just got heaps of nozzles or nodes or branches or pipe supports, moving around those with this is really seamless, and it just stops you from having to stitch everything together post acquisition, which can take you hours. And again, it just provides the client a really nice report at the end of the day.
Yeah, that was well put, Cass. In the simplicity too, man, to hit on that, you're getting this accurate, or that positional accuracy in that productivity and being able to map the way you said for something that's the next to nothing compared to automated systems. Hey.
Very, very nice. And what additional advantages have you experienced with the DLA probe versus like a manual probe for
Just
corrosion mapping?
the near surface resolution, Sean. Some of that well seam story I was telling about. There's some of those pipes, they were 4 mil thick. You can't have an interface echo and give accurate thickness measurements on 4 millimeters, because that interface eats up half the range there for you. So being able to couple this REX1 probe with this tech, just it helps you with the accuracy, man.
Very nice, very nice. Chris Rodriguez, do we have some questions in the chat? And I've got a question of my own. How readily available is evoDUAL at the moment, and how accessible and quickly can folks get a hold of this technology?
Yeah, right now we actually have them in stock in Houston at our office in Houston, ready to ship overnight. You can refer to our website and see some pricing details, or you can contact us at sales@evosonic.ai, and we can get you out a quote and get you some additional information.
Fantastic. I'm going to keep sharing.
We had a
Yep.
Q&A from Aaron Hurst. It says, will it house a Rex 2? I guess, how far off are we from that, Nate?
Yeah, so that's a fantastic point. We've been discussing design changes to not only just house the REX probes, but being able to essentially sandwich any 0 degree or even shear wave probe into this scanner. So changes are coming, gents. I don't have a firm date, but that's been quite the conversation over here in Australia for how we can better suit this to every customer here, because everybody does things differently, don't they? And the REX2, that's the larger DLA. That's the 128 element, correct?
That's correct, Nate.
Yeah, I believe so. So yeah, that's essentially we're gonna have to open that up and make it wider. So because currently it's fit for the 32 transmit, 32 receive DLAs. As you see, it's a pretty compact thing. But now, and I'll get some timelines and make sure the team gets a date to you for changes.
Great question, Aaron. Yeah, we had talked about that in the beginning as well. Creating, larger aperture and larger probe and being able to carry that. So great question. I will share. We decided to do this one first, but we'll have another webinar next month on EvoArc itself. And so we've already provided a lot of adjustments for the EvoArc. So, if you could pop up a quick snapshot of that, Cass or someone, on the EvoArc on the currently commercially available Flexiform. We've been able to improve that technology. We'll have a webinar on that next month. But in addition to the vast improvement on the Flexiform in mounting the ARC technology to the Flexiform, where now you can use the ARC technology to circumferentially scan on the Flexiform. But in addition to that, and some folks have already seen this in play. We had it recently at PPIM in Houston. We've created multiple adapters for the ARC technology that allow us to deploy it independent of this evoDUAL setup here. So we have the ability. What's so awesome about EvoArc technology is that how versatile it is, right? We adapted it here to the DLA. We've adapted it to the Flexiform. Just with a simple change in the adapters that are provided in your kit, we can attach the EvoArc to a chain scanner, various types of scanners, gyro scanners, stick scanners for weld inspection, and even independently, if you want to run dual phased array with ARC encoder, that can be done. We've recently provided and modified a scanner for small bore piping for a space customer. And so it's pretty awesome. It's awesome how versatile this technology is. So anyway, be on the lookout for another webinar next month on EvoArc. And we appreciate your time today. Do we have any more questions in the chat?
Nope, not at this stage, Sean. But
Well,
again,
we really
probably
wanna,
needed to enable that chat a bit earlier, but
yeah. We'll approve our
yeah.
webinar functionalities here on the next one, but really appreciate everyone's time today and allowing us to present to you this technology in our very first webinar. So thank you so much for joining us today.
Very much appreciated, guys.
Yeah, no, it was very fun, guys. Appreciate you. And yeah, I'll keep an eye out for you. Any questions, please fire them our way. We're here to help you guys.
Yeah, please reach out to us, ask us more. We've got a couple guys, Cass and Chris are in Houston. I'm in Salt Lake City, and Nathan is in South Australia. But you guys know how to get a hold of us, so please reach out and send us some inquiries and contact us, and we'll definitely come to you and bring it to you or send you a demo kit. Appreciate everyone. Have a fantastic day.
Thank you.
Yep. Have a great day, guys. See everybody.
Cheers, man.
Cheers.